All right, this is just sort of a review of vectors, right? But just with a different, instead of being given the numbers, you have to come up with the numbers. Yeah. You say? I think. Okay, so what we're going to do, the first question says, what is the sum of the forces on the 10? So does it make sense to you that there is this? Right? Because it's the force of the 20 on the 10, the force of the 5 on the 10, and you add those up. Right? And they're just vectors. So let me see.
Was it really asking for 10? I thought it was asking for 20.
And 20. Yeah. And then I'll do this in different, I guess a different color, whatever. Part B, oops, just kidding. Part B is asking this.
Oh. Oops.
Because it's asking for the effect on the 20. Does that make sense to everybody? Okay. So now it's just a matter of doing the calculation, right? So we know Fg is big G m1 m2 over r squared. So what you're going to do is just get F of 5 on 10 and add F of 20 on 10. For part A, it is all X and all Y. There's no anything but, right?
No, yeah, it's also you don't break it up into two different force statements for the X component and then for the Y component.
Oh no, I mean I would just do the two. Well, I wrote them as vectors. That's why. And yeah, ultimately you would break them up. Yeah. Or, I mean, you would say like for this I would go to Pythagorean, right?
Yeah.
Pythagorean and inverse tangent to get theta. That's what I would do. Questions on that part? Okay. And the reason Pythagorean requires like a sum of the forces in the X, sum of the forces in the Y kind of deal. But since they're both X and Y, it's easy. If you use the same logic right here, then when you do, obviously the vector 20 on 10 is easy, but the vector 5, well, I guess it should have been 10 on 20, but whatever. 5 on 20, that one you have to break up into its two components, right? Because part of it is this, but part of it's also that up as well. So you break them into components, then same thing, Pythagorean and inverse tangent. Okay, is that making sense to everyone? Yeah?
So the hypotenuse is the final result?
Of right here? No, let me go ahead and say I'll rewrite this. So for part A, we should be looking for this blue vector, something like that. Yes, does that make sense? And for part B, if I add these two together, we're looking for this pink vector, like that. Okay, sorry, it's a little bit busy because they're right on top of each other, but you get the idea. One of them is like this, because this is the force of 20 on 10. This is the force of 5 on 10. We add those two vectors, and we get R. And then the second one, it's kind of like this is the force of 10 on 20. This is the force of 5 on 20. And that's our R. Is that making sense? Okay. Do you need me to go through and do all of it? What's that? Oh, that's annoying. Okay, well let's try to play with it then and see how we do. All right. So this is 200 divided by 0.2 squared is 0.04. 200 divided by 0.04 is 20,000 divided by 4 is 5,000. What?
How do you find the R?
Oh, it's distance right there. So it's 20,000 times 6.67 times 10 to the minus 11. 2 times 10 to the 4. 11 to the minus 7, 12, so 13 times 10 to the minus 7. What is it? What is F 20 and 10 come out to be? Right? I can just kind of go like this, big G, and then I'm going to get inside here, I'm going to get 20 times 10 over 0.2 squared plus 5 times 10 over 0.1 squared. So what's that? Oh, what am I doing? What a retard. Just kidding. Sorry. What's that one? Yeah, it's recording. 3.35 times 10 to the minus 7. Okay. My number was off, but my magnitude was correct. Yeah. And then what's the next one? So this big G is 5 times 10 over 0.1 squared. What's that one come out to be? Oh, that's really easy. So it's the same.
Same thing.
3.35 times 10 to the minus 7. So if we have one.
Aren't you missing a 3?
I'm sorry?
3.335.
Yeah.
Okay, whatever. Sorry. I'm off by 2 100ths. Yeah.
Where'd you get 0.2 and 0.1 from?
Oh, that's the distance. R is the distance between the two objects. So yeah, and that was 20 centimeters? 20 centimeters, 0.2 meters? Right? Okay, cool. So one goes that way, one goes that way. And so well, just from this, I know our theta is 45. Now, they want to know clockwise or counterclockwise from the y-axis, correct?
Yes.
So then I would say it looks like it goes counterclockwise from the y-axis.
Counterclockwise?
45 degrees counterclockwise from the y-axis. See the blue one, right? The y-axis is like this, right?
Uh-huh.
So it's counterclockwise from there. If you want to go clockwise, it's 135 degrees.
Yeah, about. I think.
So Jessica, did you get that? Jess, how you doing? Yes? No? Okay. What'd you do? Okay. All right. Next, maybe, but you're sure you know what's going on. Okay.
Yeah, I did the same process.
Okay. So here we're going to get G. Once again, we get 2010. Well, there's no reason to redo that. Well, yeah, that one should be the same, yeah? Because it's the effect of 10 on 20. So that should be the same at 3 point. Wait, sorry, it was 3.3? 3.335. Whatever. Okay. So it's that. Now this one is big G 5 times 20. And R for this one is 0.1 squared plus 0.2 squared. Right? Because it would be the square root of those two squared, and then because it's squared, I get this. So what does that come out to be? That's supposed to be a vector. What's this?
1.37 times 10 to the -7 power, I think.
1.3 what?
3.8.
3.8 times 10 to the minus 7.
Yeah,
Okay, did everybody get that for that?
it's a bang.
Okay. So then this is considerably smaller than the other one, but whatever. We can still do it. So we get this vector, which is 3.34, and we get this vector, and that's at some angle, theta. Theta being 1, 2, 1. No, I don't know what this is. Theta being the inverse tangent. Thank you. Of 0.1 over 0.2. What's the inverse tangent of 0.1 over 0.2? I should know that. I should just memorize that.
26.5 degrees.
26.5 degrees?
26.6.
26.6 degrees. Okay, so that seems reasonable to me based on the shape of our triangle. Yeah, so that angle's 26 whatever degrees. So I just have to crack this into its two components. Let me write this bigger so people can see it. This is like 3.34. This is 1.37? 8. 1.38. This is 26 degrees. And if you want, I mean, this is a single, so you could use law of cosines or whatever you want to do. But this is 1.38 times cosine of 26. 1.38 times sine of 26. And then r is equal to the square root of 3.34 plus 1.38 cosine 26 plus, squared, plus 1.38 sine 26 squared. And then theta is going to be equal to the inverse tangent of 1.38 times sine 26 over blah, blah, blah. And I don't know why I did that at an angle.
So what is the bottom part?
It's the inverse tangent of the x over the y.
Inverse tangent of the x over the y.
Yeah, it's 1.38 sine 26 over 3.34 plus 1.38 cosine 26.
That is fine.
Okay, so what do you get for these two things? What does r come out to be?
I got 4.56.
4.56? 4.6 times 10 to the minus 7. Did you get that? First, make sure you get that value. Ouch. Did you not have the first period?
Yeah.
Oh, okay. Oh, okay. So 4.6 times 10 to the minus 7. So did everybody get that? Everybody cool with that one? Questions?
Can you go back to this page?
Oh, sure. And, okay, so quickly back to here. All right, so what do we get here for the degrees?
Like about 8 degrees in it?
What did you get?
It's about 8 degrees.
8 degrees. And of course, I think this would be 8 degrees clockwise from the positive y-axis or whatever. Yeah. Okay. So this is actually just like a chapter, what is it, chapter 3 or something like that? Vectors? Yeah.
What was G?
G is 6.67 times 10 to the minus 11.